What's up, guys? Welcome to our last lesson for Algebra 2 Honors Distance Learning. We're solving logarithmic equations today. If you're in my class, we're using these for the IXL assignments, S.7 and S.8, solving logarithmic equations. If we go ahead and look at this first example, I want us to remember changing from logarithmic form to exponential form. It's just, I think, the easiest way to solve these. The base here is 10. This is a common log that we don't see the base there. We assume that it's 10. We're just going to go ahead and change this into exponential form. So 10 to the third power is equal to, finish up your circle, u. And then I just have to evaluate 10 to the third power, which is 1,000, and I have my answer. Well, I just solved this by changing from logarithmic form to exponential form. There's many different ways that you could do this, but I think this is the easiest way. So let's go ahead and try one that's very similar. So remember, try to change this from logarithmic to exponential form, and the answer should pop right out at you. Pause the video and come back when you're done. In this u-try example, I went ahead and did 64 to the 1/6 equals u. I went around in that circle. And 64 to the 1/6 you can just pop into your calculator. 64 to the 1/6. Notice how I put the 1/6 in parentheses. Otherwise, this would have done 64 to the first power and divided that number by 6. So make sure you put that whole exponent in parentheses. And I get 2. All right, so here's our second example. We're going to do the exact same thing. We're going to convert from log form to exponential form. So I'm going to go in one big circle. 5 to the first power equals 13u minus 8. And then we just have a regular two-step algebra 1 style equation. I'm going to add 8 on both sides to isolate that u. Since 5 to the first power is just 5, 5 plus 8 is going to give me 13. I'll go ahead and divide by 13 on both sides, which is going to give me 1. And my answer is 1. So it looked a little bit more complicated than the very first example, but you're still using the same mentality. You're converting from log form to exponential form, and the answer kind of just pops right out at you. This example is similar, but we want to isolate that log first. So if you look in example 2, the log itself was isolated. This 13u minus 8 was in parentheses, so that log was by itself on one side of the equal sign. However, when we look at this u-try and we cover up this equal sign here, the log is not the only thing on that side of the equal sign. So we want to get rid of this minus 5 first. So go ahead and pause the video, try it out, come on back, and we'll go over it together. So like I said, we would add 5 here to isolate that log. So this would be log base 11 of v left over equals 1. And then we can go ahead and convert from log to exponential. So 11 to the first power equals v. And 11 to the first power is just 11, so we've got our answer. All right, 2 more examples, 2 more u-tries. For this one, we want to remember our condensing properties. This is the quotient rule, so we want to condense this into one single logarithm first. So just like in that last example, that last u-try, we had to isolate the log first. Over here, we only want one log to deal with. So because we have the same base here and because we have this minus sign in the middle, we know that we have quotient rule and that we can condense this into a single logarithm first. This would be log base 6 of v divided by 5 that is the quotient rule, equals 2. So I condensed into a single logarithm. And now I can go ahead and utilize changing from logarithmic form to exponential form, just like I did in the last couple examples. So this would be 6 to the second power equals v over 5. In order to solve this is an Algebra 1 style equation. I would obviously have to simplify this 6 squared, and I would need to get rid of this 5 in the denominator. So I'm going to go ahead and kind of do this all in one step. I'm going to multiply by 5 on both sides to get rid of that denominator. 5 times 6 squared, which is 5 times 36. V is isolated now, and 5 times 36 is 180. My answer here is 180. I'm going to give one that's very similar. Okay, remember we want to condense that into a single logarithm by using those properties. Come back when we're finished, check out our answers. Okay, so again, here we have quotient rule. So when we condense these into a single log, this will be z over 2 here equals 3. And from here, we can change this into exponential form the same way we did with example 3. I'm going to do 6 to the third power equals z over 2. I'll multiply by that denominator to get rid of it on both sides. I'm going to have to check in my calculator. 216. Which is 432. And there's our answer. Here is our last example. Notice how the logs on both sides have the same base, and they're also both isolated on both sides with the same base. When that happens, we can set these pieces equal to each other. I can set this and this equal to each other. And then this is just a normal Algebra 1 style equation. We're going to probably subtract r to get our r's together. Get that r by itself, nice and isolated. So then here our answer would be 2. Remember that when the logs have the same base, which here they're both common logs, so they both have a base of 10, we can set these pieces equal to each other. Be careful, you've got a quadratic, so you might need to remember a little quadratics for this one. Pause the video, come on back when you're done. So if I had set these equal to each other, then what I should have done was subtracted the 6 on both sides. This is like a first semester Algebra 2 kind of thing. I can go ahead and factor this into t plus 3 and t minus 2, because 3 minus 2 is a positive 1. 3 times negative 2 is negative 6. Set those both equal to 0. And I would get t equals negative 3 and t equals positive 2. Those are 4 examples of solving logarithmic equations. If you're in my class, go ahead and try S.7 and S.8, and good luck.